welcome back. This is lesson 11.7 Math Journal, Geometric Problem Solving. I will be able to correctly calculate the volume. Oh, maybe that's not. The value, sorry. The value for various real-life situations involving surface area, and volume. Vocabulary for this lesson. A solid figure is a three-dimensional shape. The base of a solid figure is that base shape. Surface is the area on the outside. A face is one of the flat sides on the outside. Lateral face are faces that are not the base. Prism, it has two bases and all the other sides are rectangular lateral faces. A pyramid has one base and all the lateral sides are triangles that meet at a common vertex. Surface area is the area of all the surfaces on the outside, and volume is the amount of space a three-dimensional object takes up. So, Sasha made a decorative rectangular storage container without a top. The box is 12 inches long, 10 inches wide, and 7 inches tall. Each of the walls are 1 inch thick. So it says, how much space is inside the box? Would this be a surface area or a volume kind of question? Okay, this would be a volume question. So we've got to find the measurements of this on the inside. Now there's a few things we need to take in mind. Let's label our box over here that we're working with. We know that the length of the box is 12 inches. So this long side would be 12 inches. The width is 10 inches. And the height is 7 inches. But something else is important for us to know. If we're trying to find the area inside, it's telling us that the width of each one of these walls is 1 inch thick. So we need to think about that. If every side is 1 inch thick, that's going to take up some of the space. So if I just did volume like I'm used to of doing length times width, which is the area of the base, and times it by the height, problem is that counts also the thickness of the box. So if I want to know how much space I can fit inside, we can't be counting how thick the walls are. So let's think about how long inside the box would actually be. So if I have a rectangle, we know that the base was 12 and the width was 10. However, we're going to have to come in 1 inch this way, 1 inch this way, 1 inch this way, and 1 inch this way, because the walls are 1 inch thick. So from here to here, how wide is it actually? How long is it actually? So if I take 1 inch off of 12 and 1 inch off this end of 12, that's only going to leave me with 10 inches inside. Now what if we're going the other direction? If we're going from here to here, we've got to take off 1 inch this way and 1 inch this way. So 10 minus 1 from this side, that's 2 inches total. That's only going to be 8 inches wide. Now, we're trying to fill up the box. So we have the base shape, which really is a rectangle after we've trimmed off those walls, of only 10 inches inside and 8 inches. Now how tall would it be? Now it's missing a top. However, we got a bottom of the box. The wall of the box from the bottom is also going to be 1 inch. So if it's already 7 inches tall but the bottom is 1 inch, we got to take that one off to tell me how tall it really is on the inside. So on the inside of the box, it's going to have a height from base to base of 6 inches, because we have to take that 1 inch off of that 7 inches. So if I want to find the space inside, the rectangle inside the box is 8 by 10. So let's find that area. So the area of the base shape, which would be 10 times 8, so that would be 80 inches squared on the bottom. But then from the bottom of the box in the inside, which is 1 inch shorter, to the top, that would be 6 inches tall. So 80 times the 6 inch height is going to give us a total of 480 inches cubed. Okay, sometimes you have to think about what's going on. You got to do a little bit of adjusting, which is why we had to adjust for what was actually inside the box because of the thickness of the walls. We couldn't just do 10 times 12 times 7 because that included the box itself, not just the space inside the box. Alright, let's do the next one. She covered the outside in special paper that cost 28 cents per square inch. How much did she spend on paper? Okay, if she's putting a special paper on the outside, is that a surface area thing or a volume? That would be surface area. We're talking about two-dimensional on the outside. Now, because it's only on the outside and there's not a top, we've got to think about all the sides we're going to have. So she's going to have a bottom to cover. She's probably going to cover the front, the back, the left, and the right, but no top. So the bottom is a rectangle, and that rectangle is 12 inches by 10 inches. Front, which is going to be another rectangle, that is 12 by 7. The back side will be the same, 12 inches by 7 inches. The left side is 10 by 7. 7 tall, 10 wide. Because remember, this is the outside of it. And the right side would also be 10 inches by 7 inches. So area of each one of these, this one would be 120 because 10 times 12 is 120. 12 times 7 is 84. So this one will also be 84 inches squared. 10 times 7 is 70 inches squared and 70 inches squared. So we found the area of all of them. Let's put them together and figure out how many square inches she's going to need. So 120 bottom, 84 if she covers the front side, 84 if she covers the back side, 70 if she covers the left side, and 70 when she covers the right side. So all together, 4 plus 4 is 8 plus all those zeros is still going to be 8. Regroup 1. 1 plus 2, 3. 3 plus 8 is 11. 11 plus 8 more would be 19. 19 plus 7 is 26. 26 plus 7 more would be 33. Regroup 3. 3 plus 1 is 4. So she needs 438 square inches of that paper. Now, did that answer the question? No, it says how much did she spend on the paper? Well, we couldn't know how much she spent on the paper until we knew how much paper she needed. So it costs this much per square inch. So that means I got to times the square inches by the cost. So 438 times 0.28. 8 times 8 is 64. Regroup 6. 8 times 3 is 24, plus 6 more is 10, regroup 1. 8 times 4 is 32, plus 1 more is 33. 0 placeholder. 2 times 8 is 16, regroup 1. 2 times 3 is 6, plus 1 more is 7. 2 times 4 is 8. Add it up. 4, 6, 10, regroup 1. 1 plus 3 is 4, plus 8 more is 12. So I get just so you can see it. 1, 2, 0, 6, 4 when I add that all up. But I need to put 1, 2 places behind the decimal. Oh my goodness, $120 on decorative paper. That's a little ridiculous in my mind. But it's going to cost her $120.64 to cover it in that special paper. Alright, she lined the inside of that box with silk that costs $1.65 per square inch. How much did it cost for the silk lining? Well, this is for somebody way fancier than my blood, but let's see how much it would cost her to line the inside. Now, inside is different. Remember how we had different dimensions because of the thickness of the walls? So let's remember that bottom, remember how we had to trim off an inch off each side? So it ended up being an 8 by 10 rectangle on the inside. So, is this a surface area or volume thing if we're lining the inside with silk? Okay, this is still surface area, but now we're talking about the inside surfaces of the box. So we've got the bottom of the inside. We're going to have the front, the back, the left side, and the right side. But there is no top on this box, so that we only have 5 sides for this one. Now the bottom, we already decided was 10 by 8 after we took off an inch from each side. So the bottom was an 8 by 10 rectangle. Uh-oh, I think the pen might be running out. Front was a rectangle. But what measurements came off of that rectangle? Let's remember, the thickness of the wood, the bottom, if we're only doing on the inside, took off an inch off the bottom, but we're going to cover all the way to the top. So it was 7 inches. 1 inch shorter means that this would be 6 inches tall. So my area of my front would be 12, or not 12, because remember on the inside it was only 10. So it's going to be 10 by 6. So 10 inches by 6 inches. The back will be the same. 10 inches, 6 inches. The left side, another rectangle. Inside, remember, it was only 8 wide, not 10, because we had to trim an inch off of each side, but it would be 6 tall. So that would be 8 inches by 6 inches. And the right would also be the same. 8 inches by 6 inches. So figure out how much silk she's going to need to line the inside of the box. 10 times 8 is 80 inches squared. 10 times 6 would be 60 inches squared. Same with this one. 8 times 6 is 48 inches squared. 8 times 6 is 48 inches squared. So we know how many square inches of silk she needs. We're going to add that together. So 80 plus 60 plus 60 plus 48 plus 48. That's going to give me a total of 0 plus 0 plus 0 plus 8 is 8, plus 8 more is 16, regroup 1. 1 plus 8 is 9, 9 plus 6 is 15, 15 plus 6 is 21, 21 plus 4 is 25, 25 plus 4 is 29. So that's 296 inches squared, because remember we're dealing with flat, two-dimensional area. But it doesn't say how much did she need, it says how much will it cost. This is how much she's using. We're going to have to times that by the cost, which is $1.65 per square inch. This is made for a king apparently. This is going to be a pricey box. 6 times 5 is 30, regroup 3. And 6 times 6 is 36, plus 3 more is 39. Regroup 3. 6 times 1 is 6, plus 3 more is 9. 0 placeholder. 9 times 5 is 45, regroup 4. 9 times 6 is 54, plus 4 more is 58. Regroup 5. 9 times 1 is 9, plus 5 more is 14. 2 0 placeholders. 2 times 5 is 10, regroup 1. 2 times 6 is 12, plus 1 more is 13, regroup 1. 2 times 1 is 2, plus 1 more is 3. Add it up, 0. 14, regroup 1. 17 plus 1 is 18, regroup 1. 1 plus 4 is 5, plus 3 more is 8, regroup 1. 1 plus 1 plus 3 is 5. And we need 2 places behind the decimal. Oh my goodness, $588 just to line the inside of this box. I hope they're putting something really special in it and they have lots of money to pay for it. So how much is it going to cost? It's going to cost $588.40 just to line the box with silk. Okay, note to self, I don't need decorative paper or silk on the inside of my boxes to make me happy. However, this box, just for the stuff that they put on the inside and outside, is going to cost $600 plus over $700 to make. Yikes. However, did we use our math to figure out that pricing? Maybe she's just dreaming and thinking, oh, this would be nice, I could do it. Would it be reasonable? Probably not. Okay, rate yourself on this concept. How do you feel about applying what you know about surface area and volume to real life situations? 0, 1, 2, 3, or 4. Take a picture and turn it in on Google Classroom.